Good morning, class. Do you have any questions about yesterday?
No, sir.
Well, okay, class. Yesterday we started talking about the world of threats. We saw, in short, that they are just an additional mechanism that is available in all current high-level languages. I mean, you will see, you know that there are threads in Java, threads in C#, threads in Python, and so on. They all have their own libraries to support threads. Now, some of these libraries are hybrid, some of them are user-level threads, but most of the time, you will encounter hybrid-level threads in these libraries. And the main idea is simple. Basically, when you start a new thread, regardless of the language, regardless of which standard we're talking about, for example, threads in Java, why not? The main idea is always the same. When you start a thread, you have to give it a function to process. Now, the syntax, of course, changes from language to language. You have to give it a function to process, to execute as a separate thread. You have to give it the parameters of that function. And you might also pass some parameters to the thread creation phase. İşte thread'i şöyle hazırlasın, şu parametrelerle falan. İşte detached olsun olmasın falan gibi. That principle never changes. And you will see that regardless of the language also, so either it is Java or .NET or C, you will see that they always provide at least two mechanisms for synchronization. And those two mechanisms are the mutexes, which are very similar to semaphores, but with very few but major also differences, and also condition variables. Now, monitors are simply, they're not anything different. Monitors are simply condition variables together with mutexes. They are a compound synchronization mechanism. But the principles that you will see in this course, and especially next week, when we will be talking about how to synchronize between threads, they are valid across libraries, across languages. So if you study well and understand what exactly is going on with these threads in the context of POSIX, that means you have already understood how to manage threads in Java, C#, Python, etc., etc. Because even though the syntax of those languages, as far as thread creation and management is concerned, might appear different, behind the curtains, it's almost identical to what is happening here, almost identical. So that's why this stuff is mandatory. That's why there is no separate course where you are taught how to handle threads in C# or Java or Python and so on. Okay, so yesterday we talked about the library functions on how to create a thread, the library functions on how to join a thread. We saw that it is very similar to wait in the processes, in the sense that when a thread calls pthread join, it blocks that thread and it waits until the thread that we're waiting for, the thread that we are waiting to complete, actually completes. And it also gives us a means, it gives us a way to collect the value returned by the thread that is terminated. Now, detachment is something that we didn't have in the processes. I mean, when you fork an exec, by default, the processes are independent from each other. I mean, that's how they are supposed to be. The parent isn't supposed to have any relation to the child. But with threads, there is no longer the limitation that we had with processes. What kind of limitation? The limitation that every process must have its own address space, and no process should be able to access another process address space. Here, that limitation doesn't exist. Here we can have 50 threads, and all of them share the same the same address space. They share the same heap. They share the same global variables, static variables, initialized, not initialized. And so we have an additional mechanism now, detachment. Pthread detached. It receives only a single parameter, the threat identity, the threat identifier, pthread T, that is going to be detached. If it is successful, it returns 0, and if unsuccessful, it will return a positive, non-zero positive error code. So if a thread executes this library function for the target identifier, that means the thread represented by the target identifier is going to be detached. Now, what does this mean? Once a thread has been detached, it is no longer possible to use pthread join to obtain its return status. So that means you cannot join it anymore. Even if you want to wait for it, it will give you an error. The thread is detached, you cannot join it. So basically by saying that I want this thread to be detached, you're basically saying to the kernel, I don't care what happens to this thread. I don't care what it returns as a value. I will not collect it. I am not going to occupy myself with freeing its resources. It is up to the kernel. I just want this thread to execute a certain function in a parallel workflow, and that's it. I don't care when it terminates. I don't care how it terminates. Just do what you're supposed to do. And that thread cannot be made joinable again. So once you detach it, you cannot join it, and you cannot make it joinable ever again. So this is a one-way operation. Detaching a thread doesn't make it immune to a call to exit, however. So just because you have detached it and the process terminates, this still means that that thread will also terminate, since exit terminates the process, which means all the threads underneath it, detached or not detached. So there is no escaping exit. Either exit, or if, for instance, the main thread calls return. By main thread, I mean if we call return in the main function. So the main thread is the one executing the main function. Now, in such an event, so when the process terminates, all the threads in the process are immediately terminated, regardless of whether they are joinable or detached. Or to put things another way, pthread detached simply controls what happens after a thread terminates, and not how or when it terminates. So basically, the only thing that it controls is whether after a thread has terminated, any other thread will be able to join it or not. Any other thread will be able to collect its return value or not. That's the only thing that it controls. Now, we can pass a second parameter to pthread create. We haven't done it yet. Remember, pthread create had 4 parameters. Here we have man pthread create 1, 2, 3, 4 parameters. The first one is the identifier of the thread to create. The second one that we didn't use so far is a pthread attr type. So basically, it's a POSIX thread's attribute struct, or a pointer to a struct, basically. Then we have the third parameter, which is the function to execute in our thread. And the fourth one is the parameter that we pass, the argument that we want to pass to the function that will be executed by the thread. Now, let's look at this second parameter that we didn't address yet. Now, it can be used in order to specify the attributes used in the creation of a new thread. Now, there are various attributes that you can pass to the thread creation phase, such as the location and size of the thread's stack, where you want that stack to be located in the address space, the size of that stack, the scheduling policy for that thread, the priority. There are several things that you can pass to it. And of course, whether the thread is going to be joinable or detached. Now, we will be only interested in the last part. So how to pass an attribute in order to say to the library that we want this thread to be detached or not. The other things are a bit, well, they are out of the scope of this lecture. Here we have a small example. It's a bit impractical, but well, this is how POSIX works. So we have the pthread type in order to contain the identifier of the thread. We have pthread attrib type in order to contain the attribute object. And so what do? We first initialize the attribute object to default values. So whatever are the default values of that system, the default values of POSIX, they are initialized in that object to those values. Of course, we check for errors as well. Then, now that we have the default values in, now we modify it in the way that we want it to be. We customize it. And for instance, in order to set it in a detached state, the object, we call pthread attrib set detached state by simply giving it the address, the pointer to the attribute object, and of course the constant pthread create detached. So now we have modified the parameter object to have the detached setting on, and then we simply call pthread create by giving it that attribute object as the second parameter. And that's it. Now, once you're done with the attribute object, once you are certain that you're no longer going to use it, maybe you might use it for the initialization of another thread. Maybe you want to create 10 threads. You can initialize all of them using the same attribute object. That's fine. Now, once you are certain that you are no longer going to use that attribute object, you can simply call pthread attribute destroy in order to destroy, so free the resources related to that attribute object. And that's it. That's as simple as it is. So by default, the default parameter, the default setting in an attribute object is for a thread to be joinable. So you have to explicitly set it to detached if you want the thread to be detached. By default, the threads are joinable. Now this code, as I explained, it shows the code shown creates a new thread that is made detached at the time of thread creation. This code first initializes the thread attribute structure with default values, sets the attribute required to create a detached thread, and then creates a new thread using the thread attributes structure. Once the thread has been created, the attributes object is no longer needed, and so it is destroyed. Yep. Any questions about thread detachment? Okay, let's continue. Threads versus processes. Now class, bunu benden duymuş olmayın. Gerçi şu anda kayıt altındayız. O da ayrı. This is one of the favorite questions. This is one of the favorite questions of certain professors in the department during the master's interviews. So when you apply for a master's program in computer engineering, you pass through an oral interview in front of the professors, and they ask you several questions, multiple questions from the undergraduate curriculum. This is one of the most often encountered questions in those interviews. What is the difference between threads and processes? I'm not going to give a name, but there is a certain professor in the department who likes this question very, very much. Not me. Okay, so what are the differences between threads and processes? Now, the advantages of a multi-threaded approach. What's the advantage of using threads as opposed to processes? Now, first of all, let's make this thing clear. Why do we use threads? We use threads in order to have multiple flows of execution, in order to do multiple things in parallel in a program. But of course, you can only use them in order to achieve this when you have a program executing on a single computer. So if you have a program that requires parallelism, so multiple flows of execution under a single process, or let's say in a single program, if that program is working on a single machine, tek makinede çalışan bir programsa, no comment Mr. Fatih. If that program is supposed to work on a single machine, on a single computer, then almost always we use threads in order to achieve this parallelism. Now, if you're going to use multiple machines in order to do something in parallel, then there is no sense in talking about threads. Bak altını çizmeye çalışıyorum çünkü kafanız karışıyor biraz bu noktada. If you are going to use two machines in order to do something, in order to execute a program in parallel, then naturally you are going to have two distinct processes. One process in machine A, one process in machine B. You cannot have one thread in machine A and one thread in machine B. No. Threads can only exist under the roof of a single process when they are executing something in parallel. So we are always talking about a program that executes on a single machine. Now, in that case, you have the option. Either you go with multiple processes on a single machine or with multiple threads on a single machine. So please, I don't want to ever hear anyone saying, I'm going to use multiple threads on different machines. It doesn't work that way. So we are always talking about the context of a single computer where we want to execute a single program. And the question is, should that program be organized in multiple processes, so with forks, or should it be organized as multiple threads? And the answer to that is almost always it should be organized as multiple threads. Why? For two very simple reasons. One, because sharing data between threads is easy. Why is it easy? Well, because all the threads already at the moment of creation, they already share the entire address space of the process. So all the variables are accessible, all the global ones, static ones, the heap, the data segment. So there is no need to create additional mechanisms like pipes and FIFOs and shared memory segments and so on and so on. So it is easier. And two, creating additional threads is much faster than creating additional processes, because fork is an expensive system call. And additionally to that, moreover, not only threads are easier to create, faster to create, but they are also faster when it comes to context switching. They are faster when it comes to context switching. It costs less to switch a process, sorry, it costs less to switch a thread than it costs to switch an entire process. However, there are also some disadvantages. Not everything is perfect in the world of threads. Number one, when programming with threads, we need to ensure that the functions we call are thread safe, or at least they are called in a thread safe manner. Now, let's say that there's a C library function, anything, a C library function X that is not thread safe. Now, if you were using multiple processes, you wouldn't have to worry about that, because they are executed, that function is going to be executed in two distinct processes, no problem. It will have its own set of variables, its own global variables, no problem whatsoever. But when you're using it in the context of a process with multiple threads, either you're going to have to make sure that that function is thread safe, or if it's not thread safe, you will have to find a version of it that is thread safe, or you will have to call it in such a manner that it will not break the operation of the thread. So basically, you will create a critical section, protect it with a mutex, and then call that function. So this is a constant burden in the world of threads. Moreover, a bug in one thread can damage all of the threads in a process, since they all share the same address space. Now, processes are isolated, which is a disadvantage and advantage at the same time, because that means they cannot hurt each other. Since all the threads are under the roof of the single process, well, that also means that they can hurt each other. So if one thread crashes, basically, that means the entire process, so all the threads crash. So you need to be extra careful when working with threads. Each thread is competing for use of the finite virtual address space of the host process. In particular, each thread stack and thread-specific data consumes a part of the process's virtual address space, which is consequently unavailable for other threads. Now, the address space is a finite resource, sonlu bir öz kaynak. And when you have multiple processes, remember from memory management, each process is under the illusion that it has access to the entire address space. So if you have an address space of 8 gigabytes, that means each process has access to 8 gigabytes. If you have 100 processes, each of them has an address space of 8 gigabytes. That's a lot. That's largely a lot. sufficiently a lot for the processes. But in the case of threads, it doesn't matter how large your address space is, all the threads share it. That means each thread has access to some part of that address space. So there is a higher chance that that address space might not be sufficient after all for the needs of your program. So you need to be careful when allocating very large amounts of memory and when you have too many threads operating at the same time. Now, how to choose what you're going to use when you want to achieve some parallelism. Now, I have repeatedly said that most of the time we select threads. So that means the advantages of threads far outweigh the disadvantages of the thread libraries. Now, some additional points. Dealing with signals in a multi-threaded application requires very careful design. Dealing with threads is very, very problematic when you dealing with signals is very problematic when you deal with threads. Signals and threads don't mix very well. And so, as I said in the beginning of at the beginning of yesterday's lecture, do not use signals when you have a multi-threaded application. Try to avoid signals as much as you can when you're working with multiple threads. They do not play well together. This doesn't mean that they are not supported. They are supported. You can still send the signal from one thread to the other, or you can still send the signal to a process with multiple threads. It's just that weird things can happen, and it requires a very careful design. Now, in a multi-thread application, all threads must be running the same program. In a multi-process application, different processes can run different programs. Now, this is not exactly a disadvantage because we can very easily set threads to run different functions. So this isn't really that important. Now, another point that you also need to take into account is that since all of the threads exist under the roof of the same process, that means they share the same file table, the same file descriptor table. So that means they have access to all the open file descriptors of the process. And since we are talking about a single process, that means they all share the offsets. The offsets. So if one thread opens a file in a process and reads n bytes, and then the other threads try to read from the same file some additional bytes, it is the same offset that will be moving in the file. There will be a single offset for the entire process and not an offset per thread. Açık dosya olduğunda arkadaşlar kaç tane açık olursa olsun dosya sürecinizin altında bütün iş parçacıkları ona erişebiliyor. Çünkü süreç başına hatırlarsanız açık dosyalar tablomuz var. Ve bir tane iş parçacığımız bir dosyayı az biraz okuduğunda o imleç bütün iş parçacıkları için hareket ediyor. Ona çok dikkat edin. Long story short, now this is just a summary of the stuff that we talked about. Long story short, the similarity between threads and processes is that they both enable us to achieve parallelism on a single machine. The differences are many. Threads are lightweight. They are faster to create. They are faster to switch. Threads are easier to communicate with. They share the same address space. They can very easily exchange data. Processes are isolated. They have distinct address spaces. They are difficult to communicate. They have to use additional mechanisms such as pipes and FIFOs and shared memory segments. And not only that, but what? Threads, as they exist under the roof of single process, they also share all the data structures associated with the process. So the signal mask, of course, the table of allocated memory pages, the table of open file descriptors, global variables, semaphores, etc., etc. But as I said, try not to use semaphores with threads. With threads, we will be using mutexes and condition variables. So yeah, So what you should remember from this is that if you have a single machine and you want to achieve parallelism, do not even think about using processes unless you have a very, very strong reason for that, and go directly for threads. Why? For reasons of efficiency and for reasons of simplicity, basically, in order to make it easier on yourself to communicate between threads. Now, as far as synchronization goes, that's an entirely different thing. We will talk about it next week. And as you will see, synchronization is not really that different from processes. You still have to worry about the same things, critical sections, how to have one thread wait for the other, and so on. But fortunately for us, we will have a much stronger weapon. So we will have a new weapon now, and that is conditional variables. And thanks to those conditional variables, together with the power of mutexes, it becomes theoretically possible to solve any synchronization problem. So you do not have to worry about, can I solve this? No, no, no, you can solve it. It's certain that you can solve it. It's just a question of you managing to come up with the solution. So theoretically, there is a solution for all of those synchronization problems, as long as you have access to one or more condition variables and one or more mutexes. So class, that's it basically. So this is the end of the lecture on threads.
Sure.
Is there a question?
Yes, I
please.
do. I have a question regarding physical implementation of threads, hyperthreading.
Physical implementation. Oh, be careful. Hyperthreading is okay. Please ask your question.
Okay. Well, I can ask this exactly the same way as I will with physical and software implementation, but mainly this is this. We see one core implementing two threads as always. We don't see one core with four threads in no CPU whatsoever. For instance, we have an Intel CPU with 4 physical cores and 8 threads, but we don't see a Intel CPU with 4 cores and 11 threads, 15 threads. Why is there a connection with 1 to 2 difference between them?
Let me show you WIPI hyperthreading. Because here you will see that it says, where is it? For each processor core that is physically present, the operating system addresses 2 virtual logical cores. So basically, hyperthreading is, well, we're talking about hardware now. We are no longer talking about software libraries of threads, etc. Now we are talking about a hardware technique, a hardware mechanism that exists on certain architectures, on certain types of CPUs. And basically the core idea of that technique, which happens to have the name hyperthreading, is that each processor core that is physically processed, for each processor core that is present, the operating system, the kernel, just addresses 2 cores. So it basically shares the workload between them when possible. So basically it addresses each core that is available, physical core that is available, as 2 logical cores. So thus, if you have 8 physical cores, that means you have 16 logical cores. I mean, that's the whole idea of hyperthreading. Now, of course, I'm not an expert on the hardware part, so these are the questions that you should be asking Alparslan Hoca, to be honest, because I am not really that well equipped in order to address it accurately. But we have a 1-to-2 relationship in this case. So according to the explanation given here, one physical core can at most support 2 operations in parallel, since it is seen as 2 logical cores by the operating system. Bilmem bu sorunuzu yanıtlıyor mu?
Okay, it certainly did. So it's a predefined, we can say, thing, way before, as I see.
I mean, there are, of course, many variations to this technology. I mean, this is not something created by Intel. I think it is due to Sun. Yes, it is due to Sun Microsystems. They have the patent for it. Here it says, while the concept behind the technology has been patented by Sun Microsystems. So this is not something new. It has been around for quite some time. Intel decided to implement it in this way. Intel decided to implement it as 2 logical cores per physical core. But of course, I don't know, but Alparslan Hoca would probably know, there might be CPUs out there where you can have 4 logical cores per physical core. In that case, that means you can execute 4 things in parallel for every core that is available. But also, there is something very important, and here it is. In addition to requiring simultaneous multi-threading support in the operating system, hyperthreading can be properly utilized only with an operating system specifically optimized for it. So just because you have bought a CPU, a new CPU with very high-tech hyperthreading technology, this doesn't mean that automatically you will be able to exploit it. So you also need to have an operating system that has been specifically optimized for using the hyperthreading technology. So the kernel must also be equipped in order to address those logical cores. It must also be equipped with a decent scheduling policy that will exploit the hyperthreading technology.
I see. I see very clearly. And I have another question, but this
Please.
is for software implementation,
Yes.
as you've talked. Is there a limit that how much thread we can use until it becomes too unstable and makes our job slower instead of faster?
There is an upper limit to the number of threads that you can create on your system. It is a constant defined by POSIX. I don't remember the name of that constant. You can look it up very easily on Google. There is an upper limit, so you can go all the way to that upper limit. But now, are you going to lose performance or not as you increase the number of threads? Now, that is something that depends on 2 things. It depends on the hardware performance. So power of CPU, speed of CPU, amount of memory, bus speed, etc. And 2, it depends on what kind of operations you execute, what kind of instructions you execute in each thread. Now, imagine this scenario. You have n threads, n being a variable number, and each thread has a considerable amount of things to do. It is a long function. It is a long function. Maybe it has a loop that needs to run, I don't know, maybe it's a loop that runs for thousands of times, and so on and so on. Now, in this scenario, you have n threads, and you might want to distribute this long volume of work, this large volume of work, to multiple threads, so that they will share the workload in order to complete it in parallel, in order to exploit the fact that you have multiple cores on your CPU. Now, you can do that. Now, why not do that? What is the possible disadvantage? Well, the possible disadvantage, of course, comes from the time that will be lost for the switches, for the context switches from one thread to the other. So the question is, from what point on do the context switches start having a considerable impact on the total amount, on the total duration of execution? Now, there is no, as far as I know, definite limit for this. So there is no, magical number saying you should never have more than 3 threads. You should never have more than 5 threads, and so on. But the general rule, as far as I know, is that since true parallelism can be achieved by actually executing those multiple threads in distinct cores in your CPU. So if you have a single core, that means all of the threads are executing on that single core. So the more context switches you have, basically the more time you lose. Now, if you have 2 cores, having 2 threads is a very good idea, because that means 2 of them can execute really in parallel. Now, if you have 4 cores, it is a very good idea to have 4 threads, because that means they will all be theoretically able to execute in parallel, truly in parallel, 1 thread per core. If you have 8 cores, 16, 32, it makes very good sense to have 8, 16, 32 threads, because they can execute, they won't necessarily execute all of them in parallel. That depends also on the kernel, because the kernel also needs to execute somewhere. But that means theoretically you can have 32 threads executing truly in parallel, one thread per core. But if you have 128 threads, but still you have 32 cores, that means still you are executing at most 32 threads in parallel, and you are losing a lot of time in context switches. So the general rule is not really a rule, it's the unwritten rule that when you surpass the number of cores available on your system, then you are starting to slowly lose efficiency in terms of efficiency. But then again, please do not be fooled by the number of physical cores available on your CPU. No, for instance, just because I said that now, some of you might think, okay, I have a CPU with 16 cores, 16 physical cores, so that means I should not create more than 16 threads. That is not exactly true. Why? For two reasons. One, your CPU might support hyperthreading, which means it will have 2 logical cores per physical core. So if you have 16 physical cores, that means you have access to 32 logical cores. So that means it is safe, in fact, to have 32 threads, basically. And the second reason is that just because you have 16 physical cores, how do you know that your operating system is equipped to exploit them? Maybe your operating system has a kernel that is only able to exploit 2 cores at a given time. And so by creating 8 threads, you're basically not gaining that much. So there are multiple things, multiple variables involved in answering that question. It's a complicated question, and there is no definite answer to it. But as I said, the general rule, or general, parantez içerisinde, general, is that the optimal number of threads is usually equal to the number of cores, either physical or logical, that you possess on your system, capable of doing things truly independently. Bilmem anlatabildim mi arkadaşlar? Biraz karmaşık bir yanıtı var bu sorunun çünkü.
You said everything very clearly, sir. Thank you very much.
You're welcome. Mr. Doruk says, Sir, I missed why we need detach and why we use the meaning of ayırmak or not. And we use the meaning of ayırmak or not. I didn't understand the second part, but I can tell you why we need detached. Now, imagine that you started your program. So when you start your program, you have just one thread, the main thread, the thread responsible for executing the main function. And that thread creates 10 more threads. So you have in total 11 threads. Now, if those additional 10 threads are not detached, so they are by default joinable, that means somebody, I mean some thread, not necessarily the main thread, but some thread needs to wait, needs to join all the other threads. Somebody needs to join them. In order to, why? In order to collect the return value from those threads, and so that the resources allocated to those threads will be freed. Now, if you don't want to bother with collecting the return value, if you have no need to collect the return value of the threads that have been created, and you want it to just automatically disappear when it has completed the function that it is supposed to execute, that's when you detach that thread. So if you don't care about the return value, if you don't care about when it terminates, just let it go. Just detach it. So when it terminates, the operating system will clean up after it, and it will simply disappear. But if you do care about the return value that the thread will return, well, in that case, it must be joinable, and you have to wait for it to join it at one of your threads. That's why we need detachment. I didn't understand the second part, the meaning of ayırmak, etc. Any other questions, class? Okay. Well, in that case, this was week number 10, I think, if I recall correctly. It's 10. Okay, so that means we have 4 more weeks besides this one until week 14, which should be our final week. Now you have already been given 3 homeworks, 1 midterm. I would also like to add this. I know that the assistants are quite behind on evaluating the homeworks, but they had a health problem, a health issue that has slowed down a bit the evaluation of the homeworks. But now they are fine. They are fine, and they are going full speed in the evaluation of the homeworks. Now, 3 homeworks and 1 midterm, so that means we will have, of course, 1 final project, and very probably 1 or 2 more homeworks. I'm not sure about the exact number yet. Besides that, as far as the midterm is concerned, I haven't decided yet on the evaluation, but we will possibly, not certainly, possibly have a demo session for the midterms with me. That is not yet decided. Okay, any questions, class, about the lecture? Okay, class, in that case, thank you for your attendance. And in the meantime, I recommend that you study well and read your textbook about the synchronization issues, because next week we'll be entering the topic of condition variables and the classic problems, the classic synchronization problems with the threads. So study everything that you can find as much as your time allows you on mutexes and condition variables, and of course monitors, which is those 2 things together. That will allow you to be prepared for next week's lecture and make it easier for you to follow the concepts that I will be explaining. Okay, so that's it, class, from me. Thank you for your attendance, and I will see you next week. Not next week. Sorry, next week? Not next week. Next week is
Bayram.
Next week is Bayram. Yes. Next week is Bayram. Vallahi arkadaşlar, şimdiden hepinizin bayramı mübarek olsun. Görüşemeyeceğiz. O zaman haftaya dersimiz yok. Çünkü bildiğim kadarıyla idari izinliyiz bir de. Pazartesi, salı ve çarşamba günü de idari izin var. O zaman demek ki 2 hafta sonra görüşeceğiz.
Pazartesi, salı da mı tatil oluyor hocam?
Pazartesi, salı bildiğim kadarıyla çıktı. Cumhurbaşkanlığı genelgesi çıktı. Tüm kamu çalışanları idari izinli sayacaktır diye. Onun da ve 11'inde.
Öyle mi? Ondan haberim yoktu.
Vallahi bana öyle bir e-posta geldi ama yani ya benim zaten yok. Pazartesi, salı dersim yok. O yüzden bir şey değiştirmiyor. O zaman arkadaşlar, yes,
Hocam,
in that case.
bitirme sunumları ne oldu?
Bitirme sunumları. We have bitirme sunumları next week.
Çünkü 12'sindeydi o.
Süper. Evet. Süper. Bitirme sunumları. Evet arkadaşlar, bitirme sunumları. Şu anda 6'sındayız, haftaya 12 13. Arkadaşlar, o bitirme sunumları muhtemelen haftaya yapılacak ya. Yani her ne kadar idari izin o bitirme sunumlarından kaçarı yok. Onlar ya tahminim, hani emin olmak için tabii ki dersin koordinatörüne sorun. Ama benim tahminim o bitirme sunumları yapılır. Hani bayram arifesi onlara engel olmaz Gebze'de. Yani yapılır onlar. Dolayısıyla siz bitirmeniz için yapmayın. Sakın yapmayın. Boş davranmayın. Hazırlığınızı falan yapın. Ancak ben yapmayı düşünmüyorum. Ders yapmayı düşünmüyorum. Dönemde bitiyordu değil mi? 4 Haziran'da bitiyordu. Öyle hatırlıyorum. 4 Haziran'da bitiyorsa hocam. Dolayısıyla o zaman bayramdan sonra 1, 2, 3 haftamız var. Zaten kaldı. 2 tane işleyeceğimiz konu kaldı. İşte onu da yapsak. 19-20 haftasında synchronization yapsak. Ondan sonraki haftada son konuyu işlesek. Ondan sonra da bir haftada için, tekrar için falan kalıyor. Rahat yetiyor vallahi hepsi. Dolayısıyla arkadaşlar yapmaya gerek yok. Yani hikayemizi pabuca sokmanın manası yok. Gayet güzel geldik bu noktaya kadar. Hem de olur. Size de bu 2 haftada ders olmayınca siz de yapın. Biraz bayramda bir dinlenin. Çünkü bu dönem bayağı bir hırpalandınız. Hepimiz aslında bakarsanız hırpalandık. Ama siz ödevlerle daha da fazla hırpalandınız. O yüzden hem bayramın tadını çıkarın. Hani bir tane ödev muhtemelen olur mu? Olur. Ama sadece için. Hani kimsenin gözü korkmasın. Hani sadece şeyleri kullanmanızı istiyorum. Şu pthread create falan, hani bir eliniz alışsın diye onlara. O kadar. Hani öyle ekstra bir alengirli falan bir şeyler olmayacak. O yüzden de hani ödevlerde düşük puanı falan olanlar varsa aranızda, ödev notunuzu biraz yükseltmek için o ödevi kullanabilirsiniz. Sıradaki ödevi. Çünkü ondan sonraki ödev biraz sıkıntılı olacak synchronization. Doruk Bey, sorunuz var. Buyurun.
Hocam syllabus'ta 3 tane valid homework göndermemiz gerekiyordu ya.
Doğru.
Bunlara midterm dahil değil mi?
Hayır. Midterm midterm'dür. Ödev ödevdir.
Peki
Dolayısıyla
hocam en sonunda hani normalde herkese 4-5 ödevse de bir tane additional homework verme şansınız olur mu peki? Bu en azından bu validation sağlamak için.
additional homework. Vallahi Doruk Bey, millet genelde ağlanıyor. Hocam yeter, istemiyoruz daha fazla ödev değil. Siz diyorsunuz daha ek
Yok hocam,
ödev olur mu?
sadece bu koşulu sağlamak isteyenler için hani yani
Hmm.
yani öyle bir durumda kalan olursa.
Vallahi Doruk Bey, öyle bir şey yapmaya kalkarsak şöyle bir sorunla karşılaşacağız. Şimdi diyelim ki şu anda ayın 6'sındayız. Ee, Dönem yaklaşık olarak şeylere doğru bitiyor. İşte ayın 4'ünde bitiyor akademik takvim. Dersler açısından en azından. Şimdi o aralar düşünün, hani ödevleri yapmış olmamız bitiriyor. 5 tane ödevi, ki onları sıkıştıracağız bu önümüzdeki bir aya. Ee, Bir de ama şey var, final projesi var. Final projesi bayağı oturaklı bir şey. Çünkü notunuzun yanlış hatırlamıyorsam %40'ı mıydı neydi? Dolayısıyla hem final projesi bir de bir ek bir ödev, hani altından öğrencilerin kalkmasını beklemek pek gerçekçi değil. Hani
Evet
bilmiyorum,
hocam.
aranızda belki şey de vardır, hani uyumaktan vazgeçmiş olup da sadece yapmaya kararlı olanlar da vardır ama ben pek gerçekçi görmüyorum onu. Final projesini yaparken bir de ek ödev yapmayı. Buyurun.
Yani hocam sadece bir ödev gelecek şu andan itibaren hani benim için belki bir sıkıntı olabilir de iki ödev gelecekse yine sağlanıyor yani illaki. O yüzden
Arkadaşlar daha 2 tane ödev gelir. Çünkü ben bu dersi hep genelde 5 ödevle falan kapatıyorum. Hani 5 ödev artı 2 proje şeklinde. Ki 14 haftaya gayet güzel yayılıyor bunlar. Ama şeyin de farkındayım. İlk haftalardaki ilk 3 ödeviniz biraz ortalamanın üzerindeydi zorluk olarak. O yüzden bu son 2 ödevde biraz şey yapacağız. Biraz şeyi düşüreceğiz. Hatta üçüncü ödev bile biraz daha şeydi. Ortalamaya doğru şöyle yaklaştı. Bu son 2 ödevde de ortalamayı biraz düşüreceğim zorluk olarak. Çünkü ağırlığı şeye vermek istiyorum. Final projesine. Evet. Dolayısıyla ek ödev olur mu? Onu zaman gösterecek. Artık bakacağız ama genelde pek öyle bir şeye yanaşmıyorum. Çünkü bunu öğrencilerden beklemek mümkün değil. Ondan sonra öğrenciler de alengirli işlere falan başvuruyorlar. Hani oradan buradan puan kapabilmek için. O yüzden pek hoşuma gitmiyor o seçenek. Başka arkadaşlar aklınıza takılan? Peki. Tamam arkadaşlar. O zaman size iyi istirahatler bayramda. Ödev dediğim
Hocam,
gibi. Efendim.
şimdi geldi aklıma. Yaz okulu durumları ne oldu? Birinden duydum sanki iptal olmuş falan filan dendi tekrar. Öyle bir şey yok değil mi?
Arkadaşlar, yaz okulları hakkında benim pek bilgim yok. Ben şu kadarını biliyorum. Bu ders proje dersi olduğu için bunun yaz okulu falan olmaz. Orasını biliyorum. Bu normal dersler gibi değil çünkü Meret. Bu 1+2.
Teşekkür ederiz hocam.
O yüzden hani olsun olmasın beni pek bağlamıyor yani.
Hocam bu konuda bir soru sorabilir miyim?
Buyurun.
Dersi 244 döneminden alanlar için bu o dönemde proje bazlı ders görünmediğinden tek ders sınavı hakkı olduğuna dair bir söylenti var. Doğru mudur? Bu konuda bir bilginiz var mı?
Arkadaşlar, eski öğrencilere yönelik bir tek ders sınav seçeneği sanırım var. Sanırım var. O 244 zamanlarından kalma. Öyle bir şey ben de hatırlıyorum. Çünkü Erkan Hoca'nın döneminde tek ders sınavları yaptık. Onu hatırlıyorum. Hatta bazen ben hazırlıyordum onları. Ama emin olmak için, çünkü biliyorsunuz yönetmeliklerde sürekli şu anda ortalık toz duman, hani tam ne geçerli kimse bilmiyor. Hani emin olmak için ya ya doğrudan bölüm başkanına sormak lazım ki bölüm başkanı da şu anda bu soruyu yanıtlayacak en ideal adam. Hani dersin geçmişini bilen kişi. Yani doğrudan Erkan Hoca'ya sorun. Hocam, hakkımız nedir bu konuda yönetmeliğe göre? Var mı yok mu? En garanti yanıtı oradan alırsınız. Ben şu anda sizi yanlış yönlendirmek istemiyorum.
Peki hocam, teşekkür ederim.
Rica ederim. Başka arkadaşlar? Herhangi bir şey? Peki o zaman 2 haftalık bir ayrılık başlıyor. Çok özleyeceğim sizi. Sizleri beni özleyeceğinizde bayağı bir şüphem var. Bir aksilik olmazsa o zaman arkadaşlar bayramdan sonra görüşüyoruz.
Estağfurullah hocam. Hayırlı bayramlarınız olsun.
Allah razı olsun arkadaşlar. Sizin de bayramınız mübarek olsun şimdiden. 2 hafta sonra da görüşmek üzere.
Görüşürüz. İyi günler hocam.
Sağ olun sizlere de.
Şimdiden iyi bayramlar, iyi günler hocam.
Sağ olun beyler, sağ olun arkadaşlar. Hoşça kalın.